Aerodynamics is the study of how air moves around objects. More specifically, it's about how objects move through the air. Think of airplanes, cars, even birds. They all interact with air in different ways. This interaction creates forces that can either lift an object, like an airplane, or create drag, like a parachute. Understanding these forces is key to designing efficient and safe aircraft. That's why aerodynamics is so important in aviation. It helps us understand how to design aircraft that can fly safely and efficiently. Camber is the curve on the upper surface of a wing. It's what gives the wing its characteristic teardrop shape. This curve is crucial for generating lift. As air flows over the curved upper surface, it accelerates and creates an area of low pressure. This low pressure above the wing, combined with the higher pressure below, creates an upward force. That's lift. The chord line is an imaginary straight line. It runs from the leading edge or front of the wing to the trailing edge or back of the wing. The distance along this line, from leading edge to trailing edge, is called the chord length. This length is important for aerodynamic calculations. It helps determine the wing's lift and drag characteristics. The longer the chord, the more lift a wing can generate. Imagine an airplane flying through the air. The path it follows through the sky is called its flight path. This path is determined by a combination of factors. These include the aircraft's speed, direction, and the forces acting upon it. Understanding the flight path is crucial for navigation and control. Section 5. Relative wind, an invisible force. Relative wind is the flow of air relative to an aircraft. Imagine you're standing still on a windy day. You feel the wind hitting your face. Now imagine you're on a bicycle moving into the wind. The wind feels stronger because you're moving into it. This is relative wind. For an aircraft, the relative wind is created by its motion through the air. It's important because it determines the direction of aerodynamic forces acting on the aircraft. Section 6. Angle of attack. Finding the balance. The angle of attack is the angle between the chord line of the wing and the relative wind. It's a crucial factor in determining lift and drag. Increasing the angle of attack increases lift, up to a certain point. However, too high an angle of attack can cause the airflow to separate from the wing, resulting in a stall. Section 7. Angle of incidence. Designing for efficiency. The angle of incidence is the angle at which the wing is attached to the fuselage or body of the aircraft. This angle is fixed during the design and construction of the aircraft. It influences the aircraft's stability and how it performs at different speeds. A higher angle of incidence generally results in more stability at low speeds. Section 8. Putting it all together, the four forces of flight. In flight, there are four primary forces acting on an aircraft: lift, weight, thrust, and drag. Lift is the upward force that opposes weight. Weight is the force of gravity pulling the aircraft down. Thrust is the forward force generated by the engines, and drag is the resistance the aircraft encounters from the air. Understanding these forces, and how they interact, is essential for comprehending how aircraft fly. Section 9. Conclusion, soaring to new heights. Aerodynamics is a fascinating field that helps us understand the magic of flight. By grasping the basic concepts we've explored, from camber to the angle of attack, we gain valuable insights. These insights allow us to appreciate the complexity of aircraft design and the delicate balance of forces. Whether you're an aspiring pilot, an engineer, or simply curious about the world around us, a basic understanding of aerodynamics is truly enriching.